Now, let's go to the periodic law. The periodic law states that the physical and chemical properties of the elements on the periodic table is a function of their atomic numbers. The physical and chemical properties of the element is a function of their atomic numbers, or is a periodic function of the atomic numbers. That's the periodic law. Now, trends on the periodic table. A trend on the periodic table is a physical or chemical property which varies at regular intervals on the periodic table. We can say which varies, or we can say which reoccurs at regular intervals on the periodic table. So that's that. A trend is a physical or chemical property which reoccurs at regular intervals on the periodic table. This word varies here. We can use reoccurs. So that's the meaning of trends on the periodic table. Periodicity now. Periodicity is the repetition of similar physical and chemical properties on the periodic table at regular intervals. The phenomenon where the same physical or the same chemical property reoccurs at regular intervals on the periodic table is what we refer to as periodicity. Periodicity is the repetition of similar physical and chemical properties on the periodic table at regular intervals. Regular intervals, what I mean by regular intervals, let me quickly explain what I mean by regular intervals using my periodic table here. You will notice that here, when you go from lithium is a metal. You now go to beryllium, metal, but less strong. You go to boron, which is a metal but less metallic. Then carbon, which is a non-metal. Then nitrogen, non-metal. Oxygen, non-metal. Fluorine, neon, non-metal. By the time you go 8 elements on the right, or 7 elements on the right, the 8th one you come to here is another metal. Can you see? You now go from, in this period, you also go from metal, semi-metal, non-metal, and so on and so forth. So you will notice that when you count another 8 elements on this row, by the time you get to potassium, you have come to another metal. That reoccurrence of similar chemical properties or similar physical properties on the periodic table at regular intervals, you can see that it is occurring. You can see that an alkali metal, all of these are alkali metals. Lithium is an alkali metal. Sodium is an alkali metal. Potassium is an alkali metal. So you are getting an alkali metal every time you go from lithium and you count 8 elements. 1, 2, 3, 4, 5, 6, 7, 8. The 8th element is another alkali metal. We call them alkali metals because they dissolve in water to form an alkali and water. Let me give you that reaction so that you can see it. All of these are called alkali metals. We call them alkali metals because they dissolve in water. For example, lithium will dissolve in water to form lithium hydroxide plus hydrogen. Sodium will do the same thing, dissolve in water to form sodium hydroxide plus hydrogen. So they dissolve in water to form an alkali, which is, in this case, the lithium hydroxide or the sodium hydroxide I just cleaned, and hydrogen. So that ability to dissolve in water to form an alkaline solution and produce hydrogen reoccurs after every 8 elements. After every 8 elements, you get another metal that behaves like that, starting from lithium. That's what we refer to as periodicity, the reoccurrence of similar physical and chemical properties at regular intervals on the periodic table. So let's go back to where we are. That's periodicity. Now we go to trends on the periodic table. Trends on the periodic table. Trends on the periodic table. So a trend is a physical or chemical property which repeats or which reoccurs. A trend is a physical or chemical property which changes gradually from left to right or from top to bottom on the periodic table. Do you understand that? A trend is a physical or chemical property which changes gradually from left to right or from top to bottom on the periodic table. So these are some examples of trends on the periodic table. First one here is atomic radius. Ionic radius, it comes next. Ionization energy. Ionization energy. Electron affinity. This is electron affinity, electronegativity, electropositivity, shielding, and what? Electrostatic attraction. All of these are some examples of trends on the periodic table. Let's now take them one by one. Number one, atomic radius. Now, the atomic radius of an atom, or the radius of an atom, is half of the distance between two atoms of an element. Oh, sorry, this is an error here. It should be atoms of an element. It's half of the distance between two atoms. Half of the distance between two atoms of an element in a covalent molecule. So let's say you want to find the atomic radius of an element X. Let's say you have an element X and you want to find its atomic radius. Just put two of its atoms together in a covalent bond and find the distance between their centers. So if you get that distance as D, half of that distance is the atomic radius. I hope you get that. Half of this distance D will be the atomic radius, because we said atomic radius is half of the distance between two atoms of an element in a covalent molecule. So that's that. I've explained all this. R is equal to D over 2. Now, atomic radius decreases. Let's now talk about the trend. Atomic radius decreases across the period and increases down the group. Atomic radius decreases across the period and increases down the group, meaning that as you go from left, lithium, let's use the second period. As you go from lithium to beryllium to boron, carbon, nitrogen, oxygen, fluorine, the atoms get more and more smaller. As you go from left to right, the atoms get smaller and smaller. We will explain the reason for this in a moment. But as you go from top to bottom, the atoms get bigger and bigger. The reason is very simple. Look at this. The reason is very simple. Look at this. Lithium is what? 2, 1. Beryllium is 2, 2. Boron is 2, 3. Carbon is what? 2, 4. 2, 5 for nitrogen. 2, 6. Then what? Fluorine is 2, 7. Meaning that each of them has just 2 shells in its atom. 2 shells in an atom, or 2 shells in its atom. In each of its atoms, there are just 2 shells. But as you go from left to right, but you will notice that as you go from left to right, the positive nucleus is increasing. How do you know that? This one is plus 3. This one, the positive nucleus is plus 4. The positive nucleus here is plus 5. Here, the positive nucleus is what? Plus 6. The positive nucleus here is plus 7, plus 8, plus 9. So that means that the positive charge in the nucleus is increasing from left to right. And okay, let me put it this way. The positive charge in the nucleus of the atoms is increasing from left to right. But electrons are getting added to the same exterior shell, to the same external shell. You will notice that here there's 1 electron here. Here there's 2 in the second shell. Here there's 3, there's 4. So since the extra electrons are getting added to the same shell or to the same outer shell, the effect of electrostatic attraction of those valence electrons by the positive nucleus is greater than the effect of shielding. So the atoms get smaller across the period. Let me put that again. As you go from left to right, the positive charge of the nucleus increases, but electrons are getting added to the same shell, to the same second shell. There's 1 here, there's 2 here, there's 3 here, 4 here, and so on. So the valence electrons get more attracted to the nucleus, more strongly attracted to the nucleus as you go from left to right. So that's why atomic radius decreases. You can see here there's +3 charge here, but here there's +9 charge in the nucleus of fluorine. So the outermost electron in fluorine will be very strongly attracted to the nucleus on this far right. That's why fluorine is the most electronegative and the most reactive element. But the case is different. That ends the trend of atomic radius across the period. Let's now look at the trend of atomic radius down the group. As you go down the group, extra shells are getting added. Look at this here. It is 2, 1. Here it is 2, 8, 1. Here it is 2, 8, 8, 1. So that tells you that the further down you go, that tells you that as you go down, the valence electron keeps getting farther and farther away from the positive nucleus. So the valence electrons keep getting farther and farther away. The positive nucleus here is what? +11. The positive nucleus here is +19. But these 19 protons, their electrostatic attraction on this last electron here is very weak. The attraction of this last electron by these 19 protons in the nucleus is very weak due to the effect of shielding. Shielding overcomes electrostatic attraction as you go down the group. What is shielding? Shielding is the pushing away of the outer electrons by inner electrons in an atom. So because like charges repel, like charges repel. Like charges repel, unlike charges attract. Like charges repel, unlike charges attract. Unlike charges attract. So electrons get pushed away more as you go down the group than what obtains across the period. So as you go down the group, shielding, the effect of shielding is stronger than the effect of electrostatic attraction. Those valence electrons, they get pushed outwards by the inner electrons more than they get attracted by the positive nucleus. So that's why down the group, atomic radius or atomic size increases down the group, because shielding is what? Shielding is greater than electrostatic attraction as you go down the group. So that's the behavior of atomic size. That's the trend of atomic size. Now, there are factors affecting atomic radius or atomic size and so on. Those two factors are shielding, electrostatic attraction, and electron configuration. I didn't include that. Let me quickly slot it in. See, electron configuration. Electron configuration. You might be asked in an exam to give factors affecting the atomic radius of an atom. The three factors are shielding. Shielding is the repulsion of outer electrons by inner electrons in an atom. Electrostatic attraction. Now, this is the attraction of outer electrons or valence electrons in an atom by the positive nucleus of the atom. And the third one, arrangement of electrons in the atom. So all of these contribute to the size of an atom. Let's now go on and explain shielding more. Shielding is the repulsion of outer electrons by inner electrons in an atom. So what it means is that in this atom now, look at this atom here. There's 2 electrons in the first shell. There's 8 in the second. Okay, let me use red here. There's 2 electrons in the first shell, 8 here, 1 here. So it is believed that because this one is negative, are you getting what I'm saying? Because this electron has a negative charge and these 8 electrons too have a negative charge, they tend to repel one another. So these 8 electrons are pushing away these outer electrons and causing the atom to get bigger and bigger. So 2 things are happening at the same time. 2 things are happening at the same time. These 8 electrons, they are repelling this 1 electron. These 8 electrons are repelling what? This 1 electron. But this 1 electron is also getting attracted towards the center by the 11 protons. You understand? But as you go down the group, the effect of that shielding overcomes the effect of electrostatic attraction as you go down the group. So atoms get bigger as you go down the group. Do you understand? And the opposite happens as you go across the period. As you go across the period, you are getting more and more protons added to the nucleus of atoms. But the electrons added are added to the same shell. You can see this one is what? This one is 2, 1. This one is 2, 2. This one is 2, 3. This one 2, 4. This one 2, 5, 2, 6, and 2, 7. So the extra electrons are getting added to the same second shell, while the positive nucleus is getting more and more positive charges. So the effect of the strong electrostatic attraction of these positive charges on the outermost electrons, you understand, is greater than the effect of shielding across the period. That's why across the period, electrostatic attraction causes atoms to decrease in size. Atomic radius decreases in size across the period. But down the group, shielding, the effect of shielding is bigger or overpowers or is more than the effect of electrostatic attraction. So atoms tend to get bigger down the group and atomic radius increases down the group. So that's that for atomic radius. And I've explained the effect of shielding and what the effect of shielding and electrostatic attraction too. Explained those. Let's go on. So ionic radius or ionic size. This is the size of an ion of an atom. Ionic radius or ionic size is the size of the ion of an atom. Now, generally, when atoms lose electrons to form positive ions, they tend to lose a shell. So this one will go now from 2,8 to what? From 281, to what? 2,8. So it has lost this outermost shell. Thus, the neutral atom is bigger than the ion. But the opposite happens when an atom gains an electron to form a negative ion. Now, chlorine here gains an extra electron to form Cl-. So, generally, due to repulsion, there's more electrons in the outermost shell, and electrons keep repelling each other. So, Cl is what? Is less in radius than Cl-, because this one tends to become larger. due to repulsion of electrons of the same charges. So take note of that and do this exercise as your classwork. Do this exercise as your classwork. That's the first part of trends on the periodic table. This topic is very essential, so please you take it very seriously. If you understand your periodic table well, you have known more than half of chemistry. If you understand your periodic table well.